in subsistence patterns, turning to different sources of food and different ways to obtain them, i.e., scavenging and hunting, had become essential for Homo sapiens survival. Hence, some believe that change itself may have been an evolutionary survival selection mechanism, and still is. A growing number of scientists think that major climate shifts may have also forged some of the defining traits of humanity. A few large evolutionary leaps in particular, such as bigger brains and complex tool use, seem to coincide with significant climate change. There are others who believe that the climate change we're experiencing now, and the changes coming in the next century, may well be the catalyst for the next change in Homo sapiens' subsistence patterns, and will engender another burst of survival-focused innovation and cooperation. Still others think this respite from the ice is likely to prove short-lived, at least in geological terms, as interglacials, during which all hominin species evolved, are estimated to have lasted no more than 10% of the Pleistocene, which lasted from 2,600,000 until 11,700 years ago. This means that for the remaining 90% of the period, the Earth was in the glacial part of its climate cycle. Research by Eelco Rowling of the University of Southampton in England suggests we are now 2,000 to 2,500 years overdue for another ice age, and the reason it has not arrived yet is the impact Homo sapiens has had on the global climate. Specifically, human activities like deforestation and the burning of fossil fuels have resulted in an atmospheric greenhouse effect that has prolonged relatively warm interglacial conditions. Homo sapiens' effects on the climate notwithstanding, the cycle will continue. This hothouse period we have helped bring about will someday come to an end, and the ice sheets will descend again. Unlike non-intelligent species that are pre-programmed and a priori evolutionarily mature, a nascent intelligent species must discover for itself how the world works, then use that knowledge to program its own mind to avoid extinction and survive. It's probably as unlikely that Homo sapiens could have developed radio, television, and most electronics without first discovering Maxwell's equations and the theory of electromagnetism, as it is for a nascent intelligent species to avoid extinction and survive if it fails to uncover and follow potential evolutionary species survival rules. So, does a universe filled with rules, laws, patterns, and models that prescribe how most things work also come with evolutionary species survival mechanisms? What are the planetary, solar system, and galactic speed bumps and patterns that unintentionally work to accelerate, slow, or block intelligent species survival? Can one begin to identify some essential survival must-haves from this brief recounting of our species' evolution and emergence from Africa? Put simply, will Homo sapiens survive or go extinct like the dinosaurs? And has evolution given us a way to find out? If the summary below hints at the beginnings of patterns, evolution might have already done so. The following are survival impacting factors one might glean so far. Luck, location, and timing of independent planetary events. Climate change driven by galactic, solar, and planetary events. Habitat and habitat sustainability or erosion driven by climate change. Ability to adapt in the face of change. Innate smarts and the ability to innovate to survive when faced with change. Freedom to choose and the freedom to migrate to survive when all else fails. In succeeding chapters, we will discover how these and others come together to form a species survival maturity model. Chapter 3. Is species survival the default evolutionary outcome? If extinction means the end of a species, then survival must mean the continuation of a species. But is extinction inevitable? Probably not, and here is why this might be so. As our knowledge of the universe increases, we are beginning to realize that nothing in the universe lasts forever. Not planets, not stars, and apparently not even galaxies. The tale of the universe is a tale of birth, life, and death. Planets form, survive, even for billions of years. Earth was formed some 4.5 billion years ago, and then get absorbed into their stars as the stars age and expand into the orbits of their encircling planets, on the way to their own extinction. To survive in such a universe, a species will need a homeworld, located, hopefully, in a relatively quiet part of the galaxy, millions of light years from a black hole or supernova. The planet should not be in the path of gamma-ray bursts, nor should it cross the path of any rogue planet or wandering meteorite or asteroid, such as struck the Earth around 65 million years ago. The species will need time to evolve, obviously, but it must also have enough time to develop and integrate a common civilization and cultural survival narrative. And it will need to prioritize and develop the technologies, innovations, and capabilities to migrate from planet to planet, from one solar system to another, possibly even from one galaxy to another, if it is to escape this natural cycle of birth, life, and death that characterizes the component bodies of the universe. It is not unreasonable to imagine that such a species will need to become a multi-planet species if it is to avoid extinction, even as Homo sapiens needed to become a multi-continent species in order to survive. Just as we were once seafarers, leaping from continent to continent, crossing oceans and scaling mountains and braving the near extinction of the last ice age, adapting and innovating and creating the technologies needed to survive each phase along the way. We must now become spacefarers, migrating from one planet to another, from one solar system to another. It may well turn out that our species will look back at its initial survival-driven migration across the planet and realize it was but a practice run, a survival pattern that we will have to keep repeating, not just across the planet, but eventually across the galaxy. What's often missing from many accounts of early human history is the role played by evolution and the planet itself, its climate, environment, and the consequent sustainability of the local habitat. Similarly, given the way things are shaping up in the early 21st century, it's possible that the planet, its climate, environment, and habitat sustainability, this time not just of local habitat, but of the entire Earth, will become again the accelerant, if not the major factor, in yet another species-wide, survival-driven migration. This time, however, it might require Homo sapiens to become a multi-planet species. The big question is, how long does an emerging intelligent species have before it must be ready to pack up and migrate to another life-sustaining moon or planet, or even to another solar system? Sometimes, to better see what might lie ahead, it helps to look at where we've been. It's safe to assume these early humans weren't seriously considering the need to abandon their familiar habitat in the Great Rift Valley of Ethiopia in order to survive, any more than leaving Earth for another planet preoccupies us today. More than likely, they probably couldn't even imagine what life away from the valley might be like, nor is it likely they had much time to prepare. And now, 70,000 years later, it is beginning to look like we, their descendants, are no more prepared to migrate to another planet in order to survive than they were to leave Africa. The obvious pattern here seems to suggest we might find ourselves in a similar position, having to leave in a real hurry, relatively speaking, ready or not. Survival-driven migration has never been and probably never will be a pre-planned human activity. So again, looking backward, we learn that the entire human race outside Africa owes its existence to the survival of a single tribe of around 200 people who crossed the Red Sea 70,000 years ago. It took 70,000 years for our hunter-gatherer forebears to go from Africa to all the other continents of Earth, and from primitive tools to the complex cultures, technologies, and capabilities that comprise our current civilization. If survival-driven interplanetary migration turns out to be more a question of when rather than if, it becomes imperative to find out how long it will take to go from a life on Earth to a life on Mars, or another planet or moon in our solar system. For this migration, we have no pattern to follow. But if global efforts to curb greenhouse gases and reduce global warming serve as a model, it could take a very, very, very long time to get prepared. Longer, perhaps, than our species might have. Did evolution leave a few breadcrumbs along the evolutionary trail to point the way? Or do Homo sapiens have to figure it all out on their own? Perhaps there is nothing as specific as the laws of chemistry and physics, but are there any clues? Is there such a thing as a species survival maturity model? As one begins to explore this question, it again helps to look back at what enabled early humans to migrate across the face of the Earth, to go from hunter-gatherers using primitive tools to modern man using computers and emerging autonomous robots, from ape man to spaceman. Due to no effort on our part, and equipped with all things necessary to thrive and survive, we find ourselves as a lone surviving emergent hominin species that came into existence some 300,000 or so years ago on a pretty remarkable planet that came into existence about 4.8 billion years ago. Our remarkable planet happens to be rotating in the habitable zone around a not-so-average star, one of billions, in a distant neighborhood of the Milky Way galaxy, far, far away from its central black hole, numerous supernovae, and gamma-ray bursts. A galaxy that is itself just one of billions, and that has existed almost as long as the universe itself. We also find that the remarkable laws that govern the birth, life, and death of planets, stars, and galaxies enable us to peer far back into the past and look forward into the future to understand their formation, evolution, composition, and eventual demise. This orderliness creates predictability, which has allowed us to send space probes and satellites to survey or rendezvous with numerous planets, and now comets, within our solar system. Can the clockwork laws that pervade the universe and order the rotation of the Earth around the Sun and the solar systems around the galaxy offer a clue as to whether naturally occurring chemical reactions that are a subset of these universal laws will also continue indefinitely if the initial conditions that jump-started life can be maintained? One answer might be, why not? Because life's basic processes are naturally occurring chemical reactions that take place given the right set of conditions, the eventual appearance of life on Earth was probably as inevitable as the birth of new stars in the galaxy. Like the formation of stars and planets, everything a life form emerging from these chemical reactions needs to survive is an integral part of the environment from which they emerge. These life-giving processes suggest that species, once formed, can continue, if not indefinitely, for very long intervals, if those life-engendering and sustaining conditions and accompanying habitat can be maintained. The dinosaurs emerged and continued for 165 million years, until their habitat changed abruptly and was no longer able to sustain them. Predicting outcomes and trajectories in the universe is all about initial conditions and the ability to maintain them. So, an essential, if not indispensable, part of maintaining initial conditions when it comes to species survival is the preservation of the habitat and environment that gave rise to the species. Survival, then, is inextricably bound to the integrity of the sustaining environment that embodies those initial conditions. Species can thus continue as long as the environment whence they arose remains available. Otherwise, they will have to pick up and migrate elsewhere to survive, or go extinct. It is unlikely that our species can survive for any meaningful length of time on the other planets in our solar system. Not on Mars or Venus, though these share the Sun's habitable zone with Earth, nor on gas giants Jupiter, Saturn, Uranus, and Neptune, though some of the many moons that orbit them might turn out to be marginally hospitable to life as we know it. It is equally unlikely that our species can continue to survive on Earth if the sustaining environment that gave rise to our emergence is destroyed. This is among the reasons Homo sapiens must look for Earth-like planets as we scour the galaxy and the universe for intelligent life, even as we set about restoring Earth's ability to sustain life. The history of Earth is replete with examples of what happens to species when their sustaining habitat is destroyed. However, these extinctions occurred through no fault of the species themselves. Our species is the only species we know of capable of destroying its own habitat, and is well along the way towards doing so. Species emerge and seem to come equipped with the potential to survive almost indefinitely through the reproductive ability of individual members of the species. This ability is probably evolution's way of ensuring species continuity and avoiding species extinction. It is probably also a hint about which side of the species survival versus extinction question evolution is on. Why is it that in a universe where everything is born, lives, and dies, evolution equips species with the innate, extinction-defying ability to ensure survival through reproduction? Why would evolution go on to jumpstart life again and again in the face of at least 15 major and minor extinction events? Not only do these actions suggest species survival might well be the default evolutionary outcome, but also hint at the existence of a built-in evolutionary bias for survival, one we are acquainted with, the so-called fight or flight response. Species survive, but individual members do not. When human parents consider having children, ensuring the continuity of the species is hardly among their considerations. Yet, like so many animal, fish, bird, reptile, amphibian, and insect species, for which bringing forth the next generation is their greatest and often only goal, each child that is born to a human parent contributes to the continuation of the species. It seems almost as if evolution has ensured species continuity in a way that neither depends upon nor requires conscious individual consent. But species survival is not the same as national, regional, or world population survival. While it may have been just a small tribe of 200 or so that set off out of Africa 70,000 years ago, there might have been several other tribes and clans, consisting of perhaps a few hundred or so earlier humans who never left, either because they could not make it out or because they chose to remain in Africa. There are, no doubt, some who would want to be among that early group of Mars settlers, but those who survive to continue the human species on other planets would necessarily be a tiny fraction of the Earth's population. So if our species could survive by some migrating to another planet, many would remain on Earth to perish in any potential extinction event that drove an interplanetary survival migration. If the experience of people affected by recent major disasters serves in any way as a guide, consider the events such as refugee flight from wars in Syria and parts of Africa, economic migrants fleeing unsustainable habitats in many regions, the earthquake in Nepal, Hurricanes Katrina, Harvey, Irma, and Maria, and various floods and tsunamis such as in India, Indonesia, and Japan. One can only imagine the chaos that might ensue if our species were aware of an impending extinction-level event, one in which the only hope for survival is to get to another planet. So, with evolution appearing to be on the side of species survival, the question then is, what else does a species need to do to ensure it goes on? As one attempts to identify what might comprise a species survival maturity model, survival must-haves appear to fall into two broad categories: extinction-causing events that can be controlled by a species, and those that cannot be controlled by a species. Depending on their stage of development, there are things and events with potentially devastating outcomes, including extinction, that a species will be largely powerless to do anything about. Items in this broad category might include location, location, location. As noted above, emergent life and consequent evolutionary species survival really does depend upon where in a galaxy that life comes into being. Earth is, luckily, located on a spiral arm of the galaxy, some 30,000 light-years away from the cluster of stars near the central regions, far away from the interstellar violence that can potentially block the emergence of, or destroy, life. However, being in a quieter neighborhood of the galaxy does not grant safety from phenomena like quasars, supernovae, or gamma-ray bursts. Indeed, scientists believe the Sun and the Solar System may have formed from the remnants of a Type 1a supernova, including the iron in Earth's core. Scientists know this because the Earth is radioactive, and because the heavy elements comprising its core, like iron and silicon, comprise the ejecta of these heavy elements synthesized in an exploding supernova. Supernovae radiate very large amounts of energy over the course of a few weeks, and if one were to occur within 30 light-years from Earth, it could result in the destruction of most of the ozone layer, exposing all life to the sun's ultraviolet rays. Combined with the gamma-ray radiation generated by the supernova, it could end all life on the planet's surface. Supernovae that close to the Earth have been calculated to occur once every 200 million years, but new evidence suggests they may occur more frequently, and one may have occurred in our neighborhood of the galaxy as recently as 2.2 million to 2.6 million years ago in the Scorpius and Centaurus constellations some 400 light-years away. Gamma rays, on the other hand, are thought to be capable of putting out more energy in seconds than our sun will emit over its entire life, and gamma-ray bursts are believed to be the most powerful event in the known universe. They are estimated to occur in our galaxy roughly once every 100 million years, and even if far, far away, might be capable of causing the same destruction as a nearby supernova. Even though most gamma-ray bursts we've detected have occurred nearly halfway across the galaxy, sooner or later Earth could be within range of an exploding supernova or the horrendous hellfire explosions of a gamma-ray burst. For any emerging intelligent species to survive in the universe, then, it must develop the means to detect and escape from such galactic and universal species extinction events. It has no choice but to become a multi-planet species as fast as it possibly can. Timing, and maybe lots of luck. Being in the wrong place at the wrong time along the planetary formation cycle or species evolution cycle, as the dinosaurs might have been, can result in extinction. Even though Jupiter has been known to repel or block errant asteroids and meteorites drawn into our solar system, there are no guarantees that one with or without our name on it might not sneak past Jupiter's watchful eye and our own vigilance, as Oumuamua, the first observed interstellar visitor, did on October 19, 2017. Non-man-made planetary events. Supermassive earthquakes, tsunamis, superstorms, hurricanes, typhoons, floods, landslides, and droughts can all cause widespread, survival-threatening disasters. While there is a timing aspect to these as well, it bears noting that these are well beyond the planetary formation time period. There are other potential solar or planetary events, such as rogue planets, as many as 200 billion are estimated to be in the Milky Way galaxy, untethered from any particular star, cruising through the blackness of space. And perhaps there are other dangers yet unknown. Glaciation and other non-man-made environment and/or climate-driven changes. These might include very rapid changes in subsistence patterns, like the ones Homo sapiens experienced during the last ice age, and apparently just barely survived. Changes in water, moisture, vegetation, the kinds of animals and plants available, food chain sources, and the survival challenges such changes might unleash. Inability to adapt and change in the face of survival-threatening events. Some believe that the Neanderthals, who had migrated some 250,000 years earlier to parts of Europe and Asia, in addition to being in much, much colder regions of the Earth, might have had their extinction hastened due to a loss of habitat caused by the impossible challenge of adapting to and surviving protracted periods of glaciation. Habitat destruction. Our species is entirely dependent on the continued existence of the planet and the supporting ecosystems that gave rise to and continue to sustain life. But Earth comes with its own set of life-extinguishing mechanisms that can help or hinder survival, depending on the timing of intelligent species evolution. Plate tectonics. Over geologic time, plate tectonics has conducted and continues to conduct an unceasing ballet of the Earth's crust, sculpting and rearranging the continents, merging them into supercontinents. Pangaea, 320 million to 200 million years ago, being the third so far, with one more in formation, and breaking them apart again, forming the now familiar pattern of continents we recognize. Some scientists believe life would have been unsustainable on many of these earlier supercontinents. So it is no small coincidence that hominin evolution, which only began some 6 million to 5 million years ago, occurred well after the breakup of Pangaea and the extinction of the dinosaurs. And yet, it was plate tectonics, combined with the end of the last ice age, that may have facilitated the migration of our forebears out of Africa, at the point where the Red Sea meets the Gulf of Aden. The breaking apart of the African and Arabian plates resulted in the formation of a land bridge at what is now known as the Strait Bab el-Mandeb between Africa and Arabia, at a time when, due to the last ice age, the Red Sea was significantly lowered. And as Walter Alvarez tells it in his book, A Most Improbable Journey, A Big History of Our Planet and Ourselves, plate tectonics, like ice ages, aka evolution, has continued to set the scene and choreograph numerous significant events that have shaped and will continue to shape Homo sapiens' history and evolution. On the other hand, ice ages and the consequent loss of habitat, as noted above, may well have driven Neanderthals to extinction and nearly ended Homo sapiens as well. All of the above are capable of causing extinctions, and on Earth some already have. Elsewhere in the galaxy, some may have prevented life from emerging in the first place. Yet, thanks to evolution, life persists, and here we are talking about it. It would almost seem like, despite the awesome arsenals for death that the universe, like Thor, has hurled at life over the eons, in spite of all the many ways intelligent life across the universe can and probably has been prevented from emerging or outright been destroyed. Like Harriet Tubman, or like Anne Frank, evolution found a way to squirrel life away, and did so on a remarkable planet with just the right environment and habitat, at just the right time and in just the right place. Here, in the habitable zone of a long-lived, relatively benign star, tucked far away out in the galactic backwaters in a distant part of a spiral arm in the Milky Way galaxy, life found a way. And yet the journey of intelligent life across the galaxy, as far as we know, is only just beginning. As threatening and frightening as the items in the above category are, evolution found a way to navigate these galactic rapids and started life, and thereby our species, on this remarkable planet. What comes next, however, might be even scarier. In this category, evolution appears to have turned species survival and habitat sustainability over to an alpha species, Homo sapiens, and a successful outcome is not at all guaranteed. Homo sapiens is the first and only species, as far as we know, with which evolution seems to have chosen to share control of an outcome that can potentially bring an end to more than 4 billion years of evolution on Earth. If successful, though, it may well be the beginning of an even more exciting phase, wherein, for the first time, evolution would partner with a species to chart the next course of this evolutionary journey. But why would evolution take such a risk? That is a question we will explore in a later chapter. What generally comes to mind when considering survival impacting factors that, unlike those listed above, can be controlled by a species are things such as climate change or global warming, air pollution, food source poisoning, habitat destruction, species extinction, and the seemingly endless wars and conflicts that result in the death, displacement, and impoverishment of millions of people, as well as the continued destruction of Earth's habitats. However, one might want to think of the above as symptoms, rather than the fundamental root causes, some of which are listed below. The ability to remain alive and stay clear of extinction-causing events. At the risk of stating the obvious, members of a species must first exist to have any chance at surviving. There has been no lack of planet-wide extinctions of entire species during the history of the Earth. In fact, there have been no less than 5 major mass extinctions, and there are those who argue that we are in the Anthropocene epoch, and it is already leading to a 6th extinction, driven by man. Habitat. Habitat viability and species survival are inseparable. The evolutionary pattern appears to be habitat first, emergent life second. It cannot be overstated that whenever evolution has given rise to life of any form or complexity, it has invariably first established a natural, sustainable habitat with everything necessary. Then, out of that habitat, life emerges, not the other way around. From this perspective, the current excitement about establishing a significant human presence on Mars appears to be following an anti-pattern. While there is lots of excitement and chatter about establishing an alternative human habitat on Mars, and a significant amount of money being spent, it is highly unlikely that such settlements can become real, permanent alternatives to life on Earth, short of terraforming the planet. There are those who seriously question whether our species would have evolved, let alone survived, if Earth had at the time remotely resembled the current conditions on the surface of Mars. For instance, it took more than 3 billion years before enough oxygen was in the Earth's atmosphere to support the rise of complex life in the form of the Cambrian explosion. There is no naturally occurring oxygen on Mars. However, while we might one day be able to migrate to and settle on other potentially habitable planets, it does not seem as though that will happen anytime soon. Until then, our species' survival is entirely dependent on the continued preservation and maintenance of the planet on which we evolved and its supporting ecosystems that gave rise to and continue to sustain life. Migration. Migration is a built-in evolutionary survival response and is common to all species. Our species ensured its survival by migrating out of Africa at a time of habitat loss due to climate change caused by the last ice age. The urge to flee and migrate to safer climes, from country to country, across oceans, from continent to continent across the planet, or eventually even to other habitable planets, in the face of existential threats, is as much built into our species as the evolutionary compulsion to reproduce. Reproduction. Most, if not all, species appear to come prepared to perpetuate their survival by the production of offspring through the fertility of individual members of the species. It would appear that unless interrupted by uncontrollable events, such as habitat destruction, most species would otherwise continue. Why is this so? Critical mass. Any species must maintain a critical mass of fertile individuals to survive. A critical mass of male and female, childbearing and non-childbearing members of a species are an essential component of continuous survival. There is some minimum number, varying by species and habitat, below which a species begins to risk extinction, simply due to the attrition dynamics of deaths and births. The interval before new offspring can themselves reproduce, predation and natural disasters, depletion and variations in food sources, and destruction of habitat. To survive, a species needs to maintain at least that minimum number of individual members of the species. Desire to survive. The desire of individual members of a species to survive appears to be built in. When that desire is aroused and becomes pervasive, individuals collectively act as one to survive. It was the desire to survive that drove early Homo sapiens to migrate out of Africa. Survival today, however, does not appear to be a major concern of Homo sapiens as a species. Neither does it preoccupy us as individuals. How important is it to the survival of Homo sapiens to cultivate, develop, and maintain a species-level survival awareness and empathy? Survival-driven ability to adapt, invent, and innovate. Survival-driven adaptations and innovations are closely associated and comprise another of those species survival patterns we have noted. Most of the tools and technologies our early ancestors came up with were driven by their need to adapt to climate, and hence habitat and food source change in order to survive. In contrast, most of our adaptations and innovations today are profit and market growth driven, the results of which often turn out to be antithetical to survival or habitat preservation. While the ability to invent, innovate, and adapt is necessary for species survival, it is not by any means sufficient, as we shall soon see. The ability of Homo sapiens to migrate from Africa across the Red Sea may have been due not to innovations and technologies, but to the massive sea level fall caused by an ongoing ice age. Maturity. Species maturity, or species extinction, is a stark choice. Avoiding extinction due to intraspecies conflicts may well turn out to be the most difficult rung of a species' survival maturity model. In addition to being intelligent and capable of amazing inventions and innovations to survive, a species must be able to overcome and eliminate all survival-threatening intraspecies conflicts, as well as other activities that can eventually lead to self-extinction. In other words, to survive, a species has to mature and make choices that reflect that maturity. The dinosaurs' ability to survive for 165 million years was clearly not dependent upon either the size of their brains or their ability to invent and innovate, and we may find that, notwithstanding our many scientific and technological achievements, our ability to survive isn't either. On the contrary, if a species can muster the courage and will to nurture and grow a species-wide empathy awareness that transcends ethnic, racial, religious, social, economic, political, national, and regional sympathies and allegiances, and if that awareness can mature faster than the species' ability to destroy itself, and grow to a sufficient level that it begins to prioritize its survival over all else, then, and perhaps only then, can it prevent self-extinction and go on to fulfill its evolutionary purpose, a subject we will explore in ensuing chapters. Unlike all other adaptations and innovations, which tend to be double-edged swords that endow a species with the potential to do both good and evil, to create as well as destroy, species maturity stands alone in its intrinsic and singular nature as a force for good. This is the aspiration around which all aspects of species activities, economic, political, scientific, and religious, to name a few, must coalesce in order to reach the final rung on the species survival maturity model. But maturity does not come easy. Unlike species survival through reproduction, where continuity of the species appears to be almost automatic, if not instinctive, species survival due to maturity is not. On the contrary, and as we shall also explore, species self-extinction due to immaturity is almost guaranteed. It is probably a safe bet that the 200 or so early humans that fled Africa were collectively concerned about their own survival. And I guess it won't be much different when, not if, our turn comes. Freedom to choose. The freedom and ability to choose at the individual as well as the species level may well become indistinguishable when choice is necessary to avoid self-extinction, mature, and survive. Evolution is obviously betting that, given the built-in desire to survive, individuals will choose survival over all else, even if that means choosing to become mature. Should the survival of an entire emergent intelligent species come down to the choices of just a few individuals, Khrushchev and Kennedy say, should the decision to engage in global conflicts be turned over to political leaders? Should the pollution, poisoning and destruction of the Earth's atmosphere, habitats, and environments, which puts at risk the survival of all members of an entire species, be left to governments, corporations, and their shareholders, all of which prioritize economic growth and profits over life and a sustainable environment? Is survival of greater value to an individual and to a species than profits? A sustainable habitat more valuable than nuclear power, oil, gas, and coal? Is maturity a better choice than life-destroying technologies and innovations? With hindsight, was it wise to develop chemical agents such as anthrax or VX, weapons of mass destruction? Just as species continuity is built in and assured by an individual member's freedom to choose to reproduce, so its maturity might depend upon the freedom of each individual to choose survival over extinction. Control of its own destiny. The freedom and ability to choose at the individual as well as the species level is closely aligned with the control, ability, and willingness of a species to act and rapidly change course in the face of impending potential species extinction events. It is becoming increasingly and distressingly common for the wishes and concerns of a people to be arbitrarily set aside by modern-day rulers and governments. It is this increasing loss of control by individual members of a species that places their survival as individuals at risk and threatens the species with extinction. So, even as galaxies, stars, and planets persist, even in a universe ensnared in birth, life, and death, similarly, species persist, even though they too evolve, thrive, and go extinct. Individual species extinction, then, is not the end of all species, any more than the birth, life, and death of an individual celestial body is the extinction of all celestial bodies. Species extinction might not be inevitable, but rather survival might turn out to be the default evolutionary outcome. But even as evolution appears to have weighed in on behalf of species survival, that support is not unconditional. Rather, it depends upon numerous factors over which a species may or may not have control, including its ability to reproduce, or the location and timing of its evolution, or whether it evolved in a sustainable habitat. Also, in the case of an intelligent species, evolution's support seems to depend on the species' ability to adapt and innovate in response to climate change or self-driven causes of subsistence pattern failures. Its ability, freedom, and willingness to choose survival over extinction, and its ability to mature and migrate to survive when all else fails. In subsequent chapters, we will turn our attention to exploring, in greater detail, these potential survival-impacting conditions, and, hopefully, tease out those evolutionary survival patterns that might comprise a species survival maturity model. Chapter 4. An Introduction to Intelligent Species Survival Patterns. Are there evolutionary species survival patterns? And if so, what are they? And what might they imply about why we are here and the spread of intelligent life across the galaxy? In view of the preceding summaries of survival-impacting factors, whose outcomes in some cases can be controlled by a species, while in other cases they cannot, the next step is to choose from among these factors and build a species survival maturity model. Next, we will try to ascertain whether or not Homo sapiens is aware such a survival model might exist, and, if not, has nevertheless been pursuing a course largely in alignment with this model. In subsequent chapters, we will examine the potential consequences of a species making it all up as it evolves. However, before going down that path, it is useful to briefly highlight parts of the intelligent species evolutionary process as it occurred on Earth, and consider how we got to now. One soon realizes that evolution, having jump-started the entire process, didn't just abandon Homo sapiens on the plains of the Great Rift Valley in Ethiopia. Indeed, evolution may not have been an absent, disengaged, and unmindful planetary process after all. On the contrary, it seems to be more of a guardian and companion, a counter-process to the universe's endless processes of birth, life, and death, in a way that turns out to be quite surprising, yet pleasing. In this chapter, we begin the process of identifying some of these repeating evolutionary species survival patterns as they become evident during a brief review of the emergence and migration of our species across the face of the Earth. It is quite remarkable that intelligent species evolution was more than 4 billion years in the making. It took evolution 4 billion years to prepare the planet to enable the transition from single-celled prokaryotes all the way to Homo sapiens, and that was only after going through multiple extinct hominin species along the way. Evolution fought against the chaotic forces of an apparently disinterested universe that seems to mindlessly destroy life. But despite it all, still found a way for life to thrive and persist. Remarkably, evolution won out, even over the universe's endless cycles of birth, life, and death. Its death-dealing black holes, supernovae, and gamma-ray bursts. Its potentially world-destroying rogue planets, asteroids, and meteorites. And its planetary orbits and solar system itineraries that pass through potentially dangerous galactic neighborhoods. No, it was not stopped, even by the nearly 700 million years of the mother of all bombardments raining down on planet Earth during the so-called late heavy bombardment period, which may have annihilated earlier evolutionary attempts. In the end, nothing in the arsenal of the universe was able to prevent the emergence and persistence of life. Evolution and life had found a way, in effect, saying that order can exist in the midst of this universal chaos. That the universal processes of birth, life, and death are not inconsistent with the evolutionary processes of species evolution and survival. That extinction is not inevitable, and that life and survival will have the last word. Because when it comes down to the question of species extinction versus species survival, evolution appears to have always sided with species survival, by endowing species with the ability to evolve and persist through reproduction and preserve their survival through migration. And when even that turned out not to be enough, as the extinction of the dinosaurs, even after surviving for 165 million years, demonstrated, evolution went on to evolve a new kind of complex animal species. This time around, though, evolution evolved an intelligent species, hominins, with the ability to do what the dinosaurs couldn't: adapt, innovate, and migrate to survive, to choose its own evolutionary outcome. Some scientists think the potential for intelligent life evolving separately and independently on some of the millions of Earth-like planets being identified across the galaxy is high. If life can spontaneously emerge and evolve on Earth, there is a pretty good chance it can also emerge on some of these planets, and probably already has. There are others who argue that the evolutionary process it took to jumpstart life on Earth, and which led to complex intelligent life, i.e. from single-celled prokaryotes to multicelled eukaryotes and to complex animal species and hominins, appears to have occurred just once. Not only does it appear that this process happened only once, but it has been so fraught with luck and chance that one wouldn't have wanted to place a wager on the probability that complex life would have ever occurred. For these scientists, then, it seems extremely unlikely that this process might have occurred again on some Earth-like planet somewhere in the galaxy. They conclude that while simple life might exist in abundance, hominins, and hence Homo sapiens, might be the first and only intelligent species to have evolved, not only in the Milky Way galaxy, but potentially across the entire universe. In their book, Rare Earth: Why Complex Life is Uncommon in the Universe, authors Peter Ward and Donald Brownlee base their arguments upon the Earth's optimal distance from the Sun, the positive effects of the Moon's gravity on Earth's climate, plate tectonics and continental drift, the right types of metals and elements, ample liquid water, maintenance of the correct amount of internal heat to keep surface temperatures within a habitable range, and a gaseous planet the size of Jupiter to shield Earth from catastrophic meteoric bombardment. One potential outcome implied by what this group of scientists is asserting might well be that if intelligent life is to eventually overspread the galaxy, then it must be accomplished by Homo sapiens, or a successor species that might evolve on Earth, and hopefully a more mature one. And that is an earth-shattering thought. If the history of intelligent life on Earth can serve as a guide, evolution might be taking this latter approach. The evolutionary pattern would dictate something such as first establishing evolutionarily mature intelligent life on Earth, then using that successful species to spread life to other planets. In other words, habitable worlds around the galaxy would be populated with mature intelligent life utilizing a single mature intelligent species reared on Earth as seedlings. On Earth, all intelligent life seems to have emerged from Africa. This appears to be the pattern employed by evolution in spreading intelligent life across the Earth, beginning first in Africa with a single hominin species, then on to all the continents across the rest of the Earth. Relying upon a species' innate survival instincts, a species' survival evolutionary pattern, evolution appears to have used climate change in the form of the last ice age and the resulting habitat loss to drive early humans to migrate, another intelligent species survival pattern, out of their comfort zone and away from the Great Rift Valley in Ethiopia, and eventually across the entire Earth. It is worth noting that intelligent life does not appear to have evolved independently or simultaneously on any of Earth's other continents, even though suitable habitats probably existed there. Neanderthals left Africa and migrated to parts of Asia and Europe thousands of years before Homo sapiens did, and were contemporaries with Homo sapiens. But the Neanderthal species was not the species that eventually overspread the entire Earth. The intelligent species survival pattern here appears to be first establish life on one continent using a single species, then use that species and continent as the base from which to launch migrations that eventually populate the entire planet. So might the same pattern be at work once again? Perhaps this time around to begin populating the solar system and the galaxy. Could climate change and resulting habitat loss once again be the catalyst that drives Homo sapiens to migrate, this time to other planets and eventually across the stars? Or will it become the cause of its extinction? Does this potential for an apparent pattern repetition imply an evolutionary master plan? Certainly not in the sense of an architect's blueprint to build a complex structure, but the perennial interplay of the universal processes of birth, life, and death on the one hand, and the apparent counterbalancing evolutionary processes of species evolution and survival on the other, could lead to an outcome that would be hard to distinguish from one that had been deliberately planned and executed. The combination of climate change and habitat loss that led to the spread of life across the Earth was not just happenstance, but more than likely multiple repeating intelligent species survival patterns at work across geologic timescales. So, as scientists begin to observe untoward climate patterns emerging again, one should be able to recognize these patterns at work in our times and view these growing changes in the climate for what they might be: a probable repetition of species survival evolutionary patterns. When executed this time, these patterns have the potential to drive our species to migrate to other planets, as surely as they drove early humans out of Africa to find safety on other continents. If it turns out that such an evolutionary survival pattern is at work, then might Homo sapiens be evolution's proto-intelligent species seedlings that it will use to populate the rest of the galaxy? And if so, then for the first time, Homo sapiens can begin to understand how they fit in, and can possibly even begin to answer that perennial question: why are we here? Perhaps our forebears in Africa asked themselves a similar question. Today, because of this intelligent species survival pattern their migration established, Homo sapiens may be better positioned to see the answer and identify what our potential part might be in what seems to be a grand evolutionary pattern, which, when fully executed, may well result in the spread of mature intelligent life across the galaxy. If Homo sapiens are indeed the only extant intelligent life in the galaxy, it would explain the deafening silence being heard by SETI, as well as answer Enrico Fermi's question: if the universe is teeming with life, where is everybody? The answer will have to be right here, on Earth, at least for now. Based on the above, there are at least two observations one might make. First, if the Homo sapiens species is positioned to potentially spread life across the galaxy, what happens if it fails to attain the level of maturity needed to fulfill this species survival evolutionary pattern? More than likely, as the dinosaurs gave way to mammals, Homo sapiens in turn would give way to another, one would hope, more intelligent and mature species. But until then, the spread of intelligent life across the galaxy, viewed from any perspective, will have suffered a huge setback, and will have to await a successor species, one capable of going boldly where no Homo sapiens has gone before. Second, evolution's bid to overspread the galaxy with intelligent life would seem to depend on an evolving intelligent species attaining the necessary maturity to avoid self-extinction. This realization brings one face to face with what appears to be yet another species survival evolutionary pattern, one we will call species-driven evolution. It would seem that evolution has dealt intelligent species a different kind of hand: the ability to participate and even control the success or failure of the evolutionary outcome, intelligent species-driven evolution. For the first time, evolution has endowed a species with the ability to control, within limits, not only its own survival, but the survival of all other species, and of the sustaining habitat itself. One potential outcome is that this species might fail. The 4-billion-year-old question is, why? Why would evolution risk this outcome? Not only was a very, very long time, 4 billion years or so, required for life on Earth to evolve an emergent intelligent species and support an appropriate set of sustaining environments and habitats, but an additional very, very, very long time might be required for that emerging intelligent species to attain evolutionary maturity, and then develop the technologies to become not only an intelligent communicating species, but a spacefaring one as well. What if it turns out that Homo sapiens is the only extant intelligent species in the galaxy? What if the evolutionary pattern to populate the galaxy with intelligent life resembles the spread of Homo sapiens across the Earth? And what if intelligent species really do need to attain that specific level of evolutionary maturity to avoid self-extinction? Might this not explain the vast distances between planets, between stars, the galactic distances that seem intended to make sure intelligent species are truly ready for that next step before they can begin migrating to other planets and on across the galaxy? To qualify for the opportunity to populate the galaxy, evolution appears to be saying that an intelligent species must be able to survive, and in order to survive, must attain evolutionary maturity. Otherwise, regardless of how smart, how inventive and innovative it becomes, without attaining evolutionary maturity, it is nothing. It will do itself in and disappear into self-extinction. And like all other evolutionary adaptations that fail to bestow a distinct species survival advantage, its one-of-a-kind ability to control its own evolutionary outcome might, in its current form, vanish with it. No optimistic member of our species would be rooting for that outcome. But one can't fault the evolutionary process for placing that maturity roadblock in our way, in order to ensure that an intelligent but immature species, as some think humans currently are, doesn't get to export and propagate that immaturity across the galaxy. But Homo sapiens still have time, and with time, who knows? Time, however, will not change the evolutionary equation: mature to survive or go extinct. It is Homo sapiens who must change in order to survive. As a fan of science fiction, I often wonder why so many authors, directors, and producers envision a dystopian future, often populated with a galaxy of warring species. I am certainly not wishing for a galaxy full of warring spacefaring nations. Are you? With the likes of Klingons, Cardassians, Ferengi, Vulcans, and other imagined species perpetuating, on an unimaginably grander scale, the failures and immaturity we now experience on Earth? Is it because we, but for the teachings and sometimes nebulous visions painted by some religious texts, have never had a concrete model of evolutionary maturity on Earth? Maybe. But that's our challenge. Maybe those who wish for an evolutionary mature human species should perhaps start imagining what that might be like, and sharing that new vision, creating the myths, writing the books, and making the movies depicting an evolutionary mature human world. I challenge movie makers and science fiction writers to create visions of what an evolutionary mature Homo sapiens world might look and feel like. Notwithstanding the evolutionary safeguards against an immature intelligent species spreading its immaturity across the galaxy, it still doesn't quite answer the question fully. Why would evolution risk